everyone, welcome to Harsh IT Lab. Harsh Verma this side, and today I am back again with same topic, high availability from the same book, Network Warrior. For those not following this series, this is the book Network Warrior, and the book states that everything you need to know that was not on CCNA examination. This book packs the practical lessons that was not studied in CCNA examination and only talks about the key things, practical information. So, without any further delay, I'm not going to read the book from cover to cover, but actually prepared notes which are stored here. So we are SSHing into my phone and study the notes and share the useful insights. So as you know, the topic for the day is HSRP. I've already made a video. My last video was around the HSRP, which stands for Hot Standby Routing Protocol. And this video will talk majorly about the GLBP, which stands for Gateway Load Balancing Protocol. This book does not get into the topic of VRRP, which was the Virtual Router Redundancy Protocol, because oftentimes the HSRP and VRRP act as a same. The only quiet difference, the striking difference is HSRP is a Cisco proprietary protocol while a VRRP is a open standard. Okay, so without any further delay, let's begin our GLBP journey. So GLBP work in a group-like environment, and up to 1024 GLBP groups on per router interfaces can be configured. With up to 4 active virtual forwarder per group can be set up. Okay, so active virtual forwarder. In short, we call this AVF. This is the actual router that or the actual interfaces that actually forwards the traffic. Because GLBP is concerned more of load balancing, uh, because of its nature, it also provides the high availability like feature. And high availability like feature in simple language means if one router goes down, the other automatically starts sharing the load, or actually in this case, basically it is an active config. In HSRP and VRRP, we studied that the second router, the standby router, only present in the network but is not forwarding any traffic. But in GLBP, every router actually divides the traffic using its algorithm. There is a multiple algorithms available in GLBP, and both routers will share the traffic. And once every single router goes down, all traffic will automatically starts proceeding with the second router, making it a a high availability protocol. Okay, so router that is forwarding packets is called the AVF, Active Virtual Forwarder. And each AVF, each active virtual forwarder, which get a virtual MAC address from the AVG, which stands for Active Virtual Gateway. So active virtual gateway, I have for sure had a word about this. So active virtual gateway, one router is elected as an active virtual gateway per group, and which act as a brain of operation. It handles the load balancing task, ARP responses, ARP address resolution protocol responses, and virtual MAC address assignment to the active virtual forwarder. Okay, by default, the GLBP load sharing mode is round robin. So round robin is one of the protocol in which every router get a chance, depending on the MAC address or depending on the IP address, which is configured by us. Okay, and not a single forwarder like HSRP, because we know that HSRP uses a single router as a gateway, and while the other is in a standby mode, it only be present and does not do anything by itself. And yes, if no load balancing is specified, the GLBP behaves like HSRP, and active virtual gateway act as an only forwarder. Okay. So in context of GLBP, and here I have written the spelling of context wrong, but doesn't matter. I will correct it. So in context of GLBP, load balancing is logically incorrect. What GLBP does is load sharing by changing the gateway advertisement when ARP request is made. Uh, so I just want to clarify what an ARP request is. Basically, ARP address resolution protocol is a protocol that binds an IP address with a MAC address. It's a layer 2.5 mechanism. So every time the ARP gets reflushes or rebuilds, it shares the load, one time for this router, second time for this router, and round robin does the same. It provides chances to all the routers present in the system. Okay, and yes, GLBP also uses something called waiting. Waiting is used, waiting not of in the time of waiting, weighing. Basically, the pronunciation should be weighing to specify a weight to some specific thing. Okay, so weighing is used to load distribution and object tracking, and the weight determines a member's relative likelihood of being chosen as a forwarding. The higher the weight, the more traffic it will allow with itself. A weighing value can be between 1 to 254, and by default it takes the value of 100. So if we want to that a router A will forward more traffic than the router B, because maybe the scenario that the router A has the faster links or router A has the higher throughput uplink. So what we can do is to assign a higher weight to the router A. Now, where we were, the weight determines the relatively likelihood of being chosen. Yes, and weighing value can be between 1 to 254, we know. And each member advertises its configured weight in its hello message. Okay, and the weight are advertised in the hello message. The weight determines a member's relatively likelihood of being chosen for forwarding. Okay, actually, I'm keep looping from the same protocol. Next is each router's single physical interfaces participates as a GLPB member for that subnet. So every router's single physical interface participates as a GLBP member for that subnet. Actually, I don't get a hold of it. What is it trying to convey? So each router's single physical interface participates as a GLBP member for that subnet. So division is on the basis of subnet, and for that subnet, one physical interface gets its participation. And finally, the AVG collects those advertised weights and use them to influence host assignment probability. The active virtual gateway collects all those advertised weights and use them to influence host assignment probability. So yes, we have already understood that the gateway is the brain of operation, and it determines by the listening all the advertised weights, it determines which router should be selected for how much of the traffic. Okay, we also have preemption in GLBP also. We studied what preemption does to HSRP in the previous video. So preemption in GLBP causes a router that becomes eligible, the higher priority or the configured to be preferred, default is 100, to seize the AVG role. So preemption here determines the AVG role. So basically brain of the operation. Using preemption, we can confirm that once a router A is available, it will become the brain of operation. It will become the AVG. And yes, GLBP lists the MAC address of the AVF actual virtual forwarder as owner ID, which need to be cross-referenced with the group member to find out the active forwarder. So basically, it's a troubleshooting step. GLBP also has a list of commands. You can find the command with a quick Google or Chat GPT search. And yes, it says that the GLBP commands are not actually very helpful. So we need some correlational help. So we can use to uh, pass multiple commands, then pick the MAC address and verify which is the actual forwarder in the group. Now these kinds of live lessons that this book provided, and I am actually very loving it. So I'm continuing this series. I study this book daily, and actually I target to make a video per daily, but some things is as expected and sometimes may not be reached, but I am just making my effort. Okay, now the GLBP object tracking can monitor the interface state, IPSLA, basically response times, and when a tracker object fail or exceed the threshold, the tracked member weighted adjusted or the gateway marker disabled, causing the AVG to stop assigning host to until the AVF until recovery. So basically, GLBP also provides the object tracking feature. We have seen the object tracking feature in HSRP in the previous video. Here, it also manages the weight, and it lowers the weight. And as soon the weight gets lower, the lesser traffic will be assigned to that router. And GLBP tracking supports hysteresis. And what is it? Hysteresis via the lower and upper keyword on GLBP waiting command. Configure the tracked object so that when cumulative weight falls below the lower threshold, the gateway is disabled and stays disabled until the cumulative weight rises above the upper threshold. So GLBP has a higher refined weight management or object tracking facility. So we can assign two kinds of weight, a lower threshold and an upper threshold. For all my audio phonetics friend, they must have known how a noise gate works. So if the voice gets below this range, it gets cut off. So it's kind of thing. So if the weight goes below this value, the weight will cut off. And it only become active again once it passes the upper threshold. So if the noise becomes the more than this level, the level we set, only then the gate opens. So only then the router becomes the active. And these scenarios I have not heard during my CCNA preparation. And I was just expecting that you also won't, because there's nothing mentioned on the online resources about this. So this is it from my side. Thank you for watching the video. Thank you for time, your patience, and hope to see you in the next one. But before finishing it, if you remember or recall correctly, I have talked about the sonnet in the last video for a little while and actually failed to explain you. I explained that sonnet is kind of a black box in networking, which is basically it is. So SONET stands for synchronous optical networking, and it's a standardized protocol used for transmitting multiple digital bit streams synchronously over optical fiber. It is designed to ensure reliable and efficient transport of voice and data traffic across WAN, wide area network. So basically, Sonnet is like a black box networking in which the ISP provides a uplink as a optical fiber. So we used to change our copper medium into optical medium, and just though that transmission device, the device that changes between the medium, shows that uplink will be up despite the other side of the router have failed. So this is the kind of downsides of Sonnet, or as an exception, that the the link monitoring cannot be used reliably in context of HSRP and with Sonnet. And that's it regarding the last video. I hope that this video might clear the doubts that was remain in the previous one. And again, thank you for watching. Thank you for joining. Please keep in my keep track acing this video, acing this series, so we can share learn new things. Thank you.